the problem states the national average number of pharmaceutical errors is 1 in 10,000 orders. You conduct an audit of one pharmacy and find that there are 3 errors in a sample of 2,000 prescriptions. So we're looking at a different interval. We have 10,000 here and 2,000 here. And we want to know is what is the probability of finding 3 or more prescription errors in 2,000 orders. So the 3 or more should give you a hint of how you have to handle it once you get the probabilities in there. I'm not going to give that away. I've pre-labeled a few cells in here just in the interest of saving some videos time for you. So the X is the number of prescription errors in 2,000 orders. And we have our X listings over here, but specifically we were looking for 3. Our error rate is 1 error in 10,000 orders. So that makes our pi equal to 1 divided by 10,000. And our N value is 2,000 orders. Using our mean of the Poisson probability distribution formula of N times pi, we can figure out what our corrected interval mu is, and that's 0.2 or 0.200 in this case, same thing. And we're looking for the rate for 3 errors. Okay, so now we have all the information we need. We can go fill this out. Since my megastat has disappeared and I haven't fixed it yet, we'll go ahead and use the Excel function. You can just go into megastat and go to the probability distributions, pick the discrete probability distribution, and then go ahead and hit the Poisson probability distribution, punch it in, and then you can get yourself a nice histogram to go along with it. So our mean now that we're using is 0.2, and in the first I did a cell reference to our 0 value because we're going to fill the whole table out. And obviously with the Poisson distribution the values can actually go up much further than this in infinite, except for the fact that we're talking about you only have 2,000 prescriptions, so it's probably not going to be more than 2,000, and we're not going to build the whole chart. For the first column we're not doing the cumulative, we're just doing the standard probability distribution. So we can do the same thing over here, same formula. We put in our X value, which is a cell reference. Our mean is 0.2, and the only difference here is we add a 1 because we are going to do a cumulative. The 0.8187 is the same for both of them. And you can see it goes up to 1, and we already know that based on our discussion before that it's not truly 1. If we expand out the decimal places, it drops off a little bit. Okay, so we have that there. We can double check. And again, because of the fact that the numbers get really small really fast, this looks like 1 here, but we can go a little further and it doesn't show up as 1, but that's just based off of the rounding differences and all. Now that you have the probability distribution table, you have enough information to finish off the problem. As a point of reference, the interpret your result really is what is your conclusion about the pharmacy operation. I was just copying and pasting this down. So you don't need to interpret your result and do the question B. They're pretty much the same thing. And there you have it.